Okay, so in this video, we're going to continue on to the next page and be talking about some new vocabulary terms that you might not have experienced or known about in your previous classes. So I went ahead and drew my circle up at the top of the notes, so you want to kind of put it on the left-hand corner. And I made it, it's pretty much the same size as the circle I did before, so about this size. And put a point at the center of the circle. Again, a reminder, this video is optional. This is just some additional notes, you know, if you want these notes because you like my style of notes. Also a reminder, these are the suggested materials, so anybody who didn't watch the review vocabulary, I do suggest that you go back and watch that, but if you already kind of know those terms, then you can move on to the new ones, and these are the suggested materials of what I'm going to use in this video. Okay, so then once we have our circle drawn, what we want to go in and do, so we're going to again label this central point as C, and then I'm going to draw a diameter. Okay, we'll call this AD. And I want to create a, let's see, I guess I'll just kind of eyeball it here. No, I don't want to eyeball it, never mind. I want to make this about 110 degrees. Okay, you don't have to be this exact, I just want to kind of make it look nice. So what I'm doing right now is I was measuring with a protractor. I wanted to measure this angle to be about 110 degrees. You don't have to be that exact again. If you want, you can just eyeball it, and then we're going to label this angle as 110 degrees a little bit later. Okay, so then we've got 3 points so far, A, B, and D, and then also draw a line kind of coming out here like this, and that's going to be point E, okay? All right, so our first new term, and I'm going to be writing this one in blue, is called a central angle, okay? All right, so what a central angle is, this is an angle formed with two radii, okay, which is just kind of the plural for radius, whose vertex is the center of the circle. Okay, so the definition of this term is kind of in the word. It's called a central angle, kind of sounds like center, because it's an angle that's being formed with the center of the circle. So some examples in this picture of central angles are angle ACB, this angle right here, okay, that's a central angle. We also have angle BCD, this angle here. I'm not going to highlight that one because I just want to highlight one to keep things neat, but we have two central angles in this picture, ACB, this angle here, and we also have BCD, this angle here. Something that would not be a central angle is this angle ADE. So notice how the vertex of this angle is on the edge of the circle, not at the center. That's the difference. Central angles always have to have the vertex of that angle right at the center of the circle. Okay. And I'm going to go ahead and highlight this. Not highlight it, but color it in as blue. Okay, and so you can either just label this angle as 110, but I went out and went ahead and measured it, so this is a more accurate, but that angle is 110 degrees, and we want to go ahead and label that because it's going to come into play later. Okay, next term that I want to write down, and this is going to kind of have a lot of stuff. So where do I want to put this? I guess we do need to kind of save room. So I'm going to go ahead and put this right here. Okay, and this is kind of a big term, is an arc. Okay, so an arc is a piece of a circle's circumference. Okay, so remember when we reviewed our vocabulary, we talked about how, the circumference of a circle is basically the perimeter of a circle, going around the whole edge of that circle. So what an arc is maybe I don't want to look at the whole thing. I just want to look at a piece of it, like maybe just from A to B, or maybe just from B to D, or E to D. So all those are examples of arcs in this picture. Okay, so couple of things about arcs. Yeah. Okay, so first of all, the way that we notate an arc, notation. Okay. So you can notate an arc with either 2 or 3 letters. So let's say that I wanted to say arc AB. Okay. I'm going to notate that with the letters that make up that arc, and then a curve on top. Okay, and then we can have, there's several different examples in this picture, so I want to list a couple examples. So we have arc AB. We also have arc B, sorry, not BC, BD. Okay, that's another example. We have arc DE. Okay. We can also use 3 letters to talk about an arc. So we could call it arc A, B, D. Okay. We could call it arc A, E, D. So that would be the arc from here all the way to here. So sometimes the reason that you use 3 letters is to distinguish which direction you're going, either clockwise or counterclockwise. So for example, if I say arc BD, I could be talking about this arc here, from here to here, or I could also technically be talking about the arc that goes from here all the way around to the other side, and then to there. So if I want to distinguish that difference, then I can use 3 letters. So instead of calling it arc BD, I could call it arc BAD. Okay. And that's going to tell someone, okay, I'm starting at point B, I'm going all the way to point A, and then coming all the way around back to D. So that's the arc that goes all the way around the edge. Okay. Okay. So some more things about arcs. Well, first of all, I'm going to highlight our main arc that I want to talk about right here, which is arc AB. So there's multiple arcs in this picture, but I want to bring special attention to this one. So we're going to highlight this one as our example. Okay, and I'm highlighting, so notice the colors. So I'm writing about arcs in pink, and I'm highlighting in pink so that those two kind of match together. Okay. So, you can measure, okay, so let's see, note. Okay. So note, an arc can be measured in length. Okay, so length would be like in inches, centimeters, yards, whatever. Okay, so an arc can be measured in length or in degrees. So we can talk about an arc in terms of length in the sense of like, okay, so since an arc is a portion of a circle's circumference, this is the same string that I used before to kind of measure out what that circumference would be. So an arc, since it's a piece of that circle's circumference, we could take this, okay, I could cut it, if I can cut it nicely, okay. And so if I want to talk about arcs in terms of length, I'm talking about the length of that actual piece of that circumference. So if I were to take this string, cut it off, measure the length of that string, that's my arc length. But we can also talk about arcs in terms of like how wide that arc is in degrees. And so when we talk about arcs in terms of degrees, the measure of that arc is going to be the same as the measure of the central angle that intersects that arc. So if my central angle here is 110 degrees, then I would also say that this arc right here is 110 degrees. Okay, so we're going to write that down here. So, okay, an arc's degree is equal to the measure or degree of the central angle that intersects that arc. This is also the reason why I wanted to give this angle a measurement here. So since this central angle is 110 degrees, we would also say that arc AB is equal to 110 degrees. So for example, okay, put a little m that stands for measure. Okay, measure of arc AB is what this is saying, is equal to 110 degrees. Another example, okay, let's say we wanted to give the measure of arc BD. Okay, so notice, okay, this is going to be tying in some other information that we've learned about before, but you know, AD is a straight line. Straight lines are 180 degrees. So if I wanted to find the measure of arc BD, I could do 180 minus what we have, 110. Okay, that gives me that this measure of that central angle would be 70. Okay, that's also the measure of the arc here. The measure of arc BD would also be 70 degrees. Okay. All right. Arcs can be broken into two types. You can either have a major arc. Okay. These are arcs. Okay. Let's see. Let's just kind of abbreviate this definition. So these are arcs where the degree is more than 180. Okay. Or you can have minor arcs. Okay. And this is where the degree is less than 180. Okay. So both of our examples here are 110 and 70. These are both examples of minor arcs. Okay, so an example of a major arc would have to be something that was more than this arc AD. So something like DAB, that would be a major arc. And we could really even figure out the measure of that because we know from here to here, that's half the circle. It's made, you know, with a straight line. So this arc right here is 180 degrees. If we added to that the measure of arc AB, that means that this arc DAB is 290 degrees. So let's go ahead and put that as an example. Okay. So this is an example of a major arc. So arc DAB, DAB is equal to 290 degrees. Okay. And let's go ahead and put an example of a minor arc. Okay, so BD was 70 degrees, and also AB was 110 degrees. Those are both minor arcs. I'm kind of running out of room here. Okay, so kind of scooting down, hoping, crossing our fingers that we have enough room for the last two definitions. Okay, so I'm going to kind of section this off. So a lot of this paper is being devoted to talking about arcs. Okay. So just so you can kind of get a whole picture of what my notes look like right now. Okay, this is what we're down to. Okay, so before we talk about the last two terms, I kind of want to pause and do two examples. Now, if you want, you can copy these examples onto the next page. Don't put them down here, put them on this next page. So you can devote to these examples if you want to have those. You don't have to have these in your notes. I'm just going to be working on them on a dry erase board. So if you want to have these as scratch paper or just watch and follow along, that's fine too. Okay, so in this example, we've got this circle. We want to name, it's asking us to name a minor arc, a major arc, and then find the measures of a couple of different things. So, okay, let's start by naming a minor arc. So a minor arc is going to be anything that is less than 180. So see how EA is a straight line? So basically anything, so this is like half of the circle and that's half of the circle. So any of the arcs that are smaller than half of that circle would be considered minor arcs. So like ED, okay, that's a minor arc. We could say FB, that's a minor arc. BA, we could say FA. Okay. DA. I can go on, you know, there's more. But that you get the gist of it. Okay, now a major arc. So here's kind of the difference. If I want to talk about a major arc, like I could also say ED is a major arc if I was talking about going from E all the way around to D. And so typically when you name major arcs, you want to use 3 letters to kind of describe that, okay, we're not going from here to here. We're going from here all the way around to the other side. So I could call this arc EBD. And that clarifies that I'm talking about going from here, you know, all the way around back to D. Okay, that's that major arc there. As opposed to the minor arc ED. Oops, let me get blue. Okay. The minor arc ED, which just goes from there to there. Okay. And of course, there's more major arcs. Like we could say, F, D, E. Okay, from here to here to here. Okay, that's another major arc. We could say B, E, A, from here all the way around to there. That's another major arc. I'm going to erase some of this because I want to keep my picture neat. Okay, now it actually wants us to go in and find some of the measures for this. So the first thing it asks is it wants to know the measure of angle DCA. So the measure of this angle right here. I want to erase these colors. Okay, so notice how EA is a straight line. We know straight lines are 180 degrees. We're already given that this angle right here is 90. So if I wanted to get the measure of this central angle DCA, 180 minus 90, okay, leaves us with DCA also being 90 degrees. Okay, next question. It asks us what the measure of arc DA is. So notice the different symbols here. We have an angle symbol for DCA. We have the arc symbol for DA. So again, as we just talked about, the measure of an arc is the degree of an arc is the same as the degree of the central angle. This is a central angle since it's connected to our center point C. I guess that really the problem should have specified that, but yeah, this is our center point C. So since this is a central angle, that means that the measure of this arc is going to be the exact same. So the measure of arc DA would be the same as the central angle. So if this is 90, that's 90. Next, it's asking for the measure of arc EF. Okay. We have learned in the past, okay, that vertical angles are congruent to each other. Okay, vertical angles are angles that are straight across from each other when you have two intersecting lines. So we have this line EA and this line FD that are intersecting each other. That means that this angle and this angle are vertical. So if this angle is 90, this angle is also 90. Okay? Which also means, okay, that if this angle is 90, this arc is going to be 90. Okay? So the measure of arc EF would also be 90 degrees. Okay? And then the last thing it's asking us for is the measure of arc FA. So from here to here. Really, this even could have been more specific and said FBA, so you know exactly which direction to go. Okay, so there's really a couple of ways that you could think about this problem. One, you know from E to A, okay, this is a straight line, which is 180 degrees, so 180 minus 90. Okay, the 90 that we have here would mean that this would also need to be 90 degrees. Okay. You could also see how this angle right here, being 90 degrees, is vertical with this angle here. So if that's 90, then again, that will need to be 90 degrees. Okay. If you have any questions about how I solved this problem or about how I'm going to solve the next problem, feel free to leave those questions in the comments. I'll try to address them when I can. But yeah. Okay. Here's another example. So this time around, we have a circle where our center of the circle is at this point D. This time, we're told that arc AB is 130 degrees. Oh, yeah. Actually, this did not notate properly. We need to put these arcs. Okay. And M for measure. Okay, so the measure of arc AB is 130. The measure of arc BC is 100. And it wants us to know the measure of arc ABC, so from here all the way to here. So this is pretty straightforward. I mean, if you know that this is 130 and that's 100, you just need to add those. So I'm going to do this in purple. So let's see, we've got 130 plus 100. Actually, let me write it out lengthwise because it's coming back in later. 130 plus 100 equals 230. Okay. So that would be the measure of the arc from here all the way to here. Okay, now the second part of this problem, it says use letters to write a statement describing the arc addition for ABC. So sometimes in problems, just like we've seen in other problems before, it's not going to necessarily write out this information with numbers, but it's the same idea. So if I'm trying to figure out what the measure of arc ABC is equal to, I'm taking arc AB, okay, I'm adding arc BC, okay, which was 100, and that is equal to the measure of ABC. Okay. So if I want to write a statement using letters, okay, that's exactly what I'm going to write. AB plus BC is equal to ABC. And you kind of have to get comfortable to seeing you know, things being written out in terms of letters instead of in terms of numbers, because especially when we get into some of the proofs for this circle stuff, they're not going to use numbers to describe the arcs. They're going to be using letters to describe the arcs. So just this point of this problem was just to kind of help you understand what that means whenever you're looking at a statement like this. This is just saying that you're taking this arc here, whatever the measure of that arc is, you're adding this piece here, and when you put those pieces together, it makes the full arc, ABC. Okay, so now that we've got those two examples out of the way, we have two last terms that I want to talk about. So the second to last term, okay, that I want to talk about is called a sector. Can you even see that? Orange. I think I'm going to have to use colored pencil for this one. Give me one sec. Okay. So this is a sector. Okay. So what a sector is, this is an area. So a lot of what we talked about so far has been in reference to either angles or lines. So a sector is an area of a circle, okay, that's formed by two radii and the connecting arc. Okay. All right. So an example of a sector. Let's say that we had this arc AB, and basically I wanted to figure out what the area of this piece of the circle would be. That area is what we would call a sector. Okay. So like whenever you're being asked to find something, like maybe you're trying to find the area of a pie slice or the area of a pizza slice or something like that, what it's actually asking you to find is the area of a sector, what that section. Sector kind of sounds like section, and that's kind of what it is. It's a section of a circle. Okay. So notice I shaded this in orange, and we wrote our definition for sector in orange so that those things are related to each other. And then our last term, yay, we still have room, is chord. And it's spelled like chord, okay, but it's pronounced chord. So this is a segment. Sorry, my husband's sneezing in the background. This is a segment connecting two points on a circle's circumference. Okay, so a chord, unlike a radius, is any line or any segment that connects 2 points on the circle's edge. So an example in this picture of a chord would be like line ED. You might be wondering, well, also, a diameter connects 2 points on a circle's edge. So a diameter is a type of chord, but a chord where a diameter has to go through the center of a circle, a chord is less specific. A chord doesn't have to go through the center of a circle, but it can. So some examples in this picture of chords would be line ED and line AD, okay, or segment ED and segment AD. This should be more specific. So the examples, okay, in this picture are segment AD, okay, and ED. Okay. Side note that this is also the diameter. Okay, ED is not the diameter, but AD is also the diameter. Okay, and I'm going to go ahead and highlight this one green so that it matches our chord. So this is an example of our chord. All right, and that pretty much makes up our notes for the vocabulary for circles. So if you want to get a full picture, if you can see all of that, okay, this is what it is in total. So this is going to be our lesson for today pretty much. And then tomorrow, what I want to get into is we're going to start talking about things like inscribed angles and what it means to inscribe something, and going into a couple of theorems about that. So hope y'all are doing well, and I'll see you, or not see you, but hear from you, post a video tomorrow. If you have any questions about anything that I went over today, feel free to leave those questions in the comments. I'll try to be checking them. I'm going to be active online until about 2 o'clock. After that, I may or may not respond. But until 2 p.m., I'm going to be actively checking comments to see, if you have questions or whatever. So just let me know. Bye.